Well, welcome to our seminar. So today we have as a speaker of a seminar Jan Meizner. Jan is a PhD student at the Extreme Scale Data and Computing team at Sano Center. Well, this is one of this series of seminars about result of research of PhD students at Sano. And Jan will, who has played different roles in the time of establishment of Sano. He was one of the persons responsible for all this IT infrastructure. At one point decided to become a PhD student, and Jan will present the result of his research. But before Jan starts his talk, I would like to invite to few words about this research. Maciej Malarski, director of Sano, and at the same time leader of this XM Scale Data and Computing team. Maćku, floor is yours.
Hello, I hope you can hear me well.
Yes.
So, nice to have all you here. Yeah, as Marian introduced, Jan has worked at Sano as a technical manager responsible for IT solutions, infrastructure, all the servers and more than that we have here. But actually, even earlier, he worked with us for our team earlier at Cyfronet in many European projects and national projects regarding computing infrastructures, high performance computing. So his expertise is also in security. So his first research was about security protocols, authentication, authorization, in the case of various distributed infrastructures and data, especially medical data. He also worked on aspects regarding to data access in clouds with some challenges regarding to secure storage in multi-cloud environments. He was also involved in research regarding testing, deploying cloud infrastructures and testing medical applications on these infrastructures, yeah, especially during the VPH share project. Yeah, after some break for having more technical role, recently Jan decided to finally complete his research work with a PhD. So he formally is now a PhD student in my team. Yeah, the theme of the research from his earlier work, but also the current work is about applications, especially medical applications on on these emerging computing infrastructures, especially new setups of HPC, but also cloud, and with a special focus on performance. So, yeah, I think this is the main introduction from my side, and I hope that you will see the examples of applications and tools, and it would be also interesting to see if there are other applications, other tools, other infrastructures that can be also subject to Jan work. So this is a kind of introduction for collaboration as well. Okay, thank you.
Thank you very much. And as usually, once you have a question during Jan's talk, well, for this formal reason, please put these questions in chat or questions and answers. And of course, after the talk, we will, as usually, have a discussion. So then it will be opportunity to ask, let's say, questions of different type. So, Jan, screen is yours from that moment.
Okay, yeah, thank you very much for the introduction. I hope you can hear me all. And of course, I'd like to welcome everybody to my seminar. So the title is on the screen. Basically, as it was said, my work focuses on various kind of infrastructures, or what they call infrastructures, and well, one of the most crucial aspect of it is providing sufficient performance and means to run everything smoothly. So, well, why? So this is probably the first question. Below this question, you can see an example of some basic metrics from an application. One quite typical compute-intensive application for medical for various type of physics simulations, including medical one. And this is also an example how not to utilize infrastructure. So we have a really huge node with 48 cores and lots of memory. But as we can see, only one core is utilized in 100%, but only one core and only a fraction of memory. So if, as this was run for just for test purpose in the cloud, if we keep running it that way, we would basically, lose resources. So lose both money, lose electric power, everything. Yes. So it would be neither economical nor green, and this is why there is such need to find appropriate infrastructure for given task and way to run each workload in sufficiently or in a proper way. Let's put it that way. So also, of course, there are many reasons why application might not run smoothly. There may be different bottlenecks, and well, our task is to find those bottlenecks for specific application or for a class of applications. It's all, and find a most broad solution applicable to the widest range of similar cases. Also, as Maciej said during the introduction, I worked a lot in the field of security. So this is also important that obviously without security there is no way to run a computation, especially in the field of medical science. But at the same time, obviously, every mechanism to secure data storage, data transfer, data processing comes with some overheads. So huge aspect of my work is to find balance between well, security and user and performance, yes, to put it that way. So how? Well, there are different mechanisms. I'll speak a bit more about them further in this presentation, but basically we need to collect some data from either infrastructure or applications, like application itself or logs. We can visualize them, but of course the most important aspect is not just to produce pretty pictures, but also to let's say to provide analysis how we see ways to improve it. So also as was mentioned, I've already been doing some research previously. So during my PhD, I would like to continue work as much as possible. So I formulated a set of research questions based on my previous work. So one is how to efficiently monitor workloads on multiple extreme scale deployments to identify bottlenecks and optimal setup. Of course, well, the term extreme can be related to exascale, obviously, but also to it's with time its meaning it applies to well current state of the systems. So the previous work also was applicable to state at that time. So here I am well mentioning the work I've done in a process project, which is also a project about well preparing for exascale. It was still before the first exascale computer in US and generally in the world was deployed. So well we that was of course the team effort, but we've built an infrastructure in which design I took part, providing well suited for hybrid infrastructure composed of well 2 HPC clusters, one at Cyphernet in Krakow, one in LRZ in Munich, and also some cloud resources in Slovakia. And of course, one of the core components was related to monitoring and collecting metrics. There we tried one of these off-the-shelf solutions. It had some merits, but also some drawbacks, which I will mention later. But of course, that was a start of those. Well, yeah. The second question is well, how to use modern paradigms, because obviously there are different ways to run computations. We can use just well good old cluster batch processing, yes, which usually would lead to the best solutions performance-wise, but might not always be feasible for everything. We may use different mechanism for virtualization or containerization. So not every container system works well for a different for a given infrastructure, because for example most common Docker is usually not supported on HPC. Well, the other the singularity now known as container is more useful, but well, from my point of view, this is also a set of challenges how to provide and analyze workloads on all those infrastructures, and in turn how well to address the need to find best well, either best infrastructure or sufficient one, because there are various aspects what we can consider sufficient. For some computations, we can run calculations for a few days, and it won't be a problem, for example, to create some model that will be reused later. For others, we may even need some near real-time or faster than real-time solution. Another one I already mentioned is related to, well, used to different aspects of security. So also there was work done in the scope of the Eurovault project. So there was a platform, and it composed an encryption module. It's crucial, especially if we want to use clouds, because we have no control over the, let's say, backend in the cloud. So it's, while obviously every cloud provider assures us that what we are doing is, well, secure and etc., but it's always good to have your own mechanism to let's say ensure that it's really not just hard to extract data during computations or storage or time it's supposed to be stored, but also afterwards. So there is a case, for example, of so-called ensured deletions, so that we know that the data cannot be recovered while it's deleted. It's not always assured by the platform. So then we need to do our own work. But as I said, obviously it imposes some overheads, and it's interesting and how that impact can be minimized So of course, also we are now dealing with different type of architectures. It's even, there was a period of time when practically everything was running on x86 infrastructure. So Intel architecture, of course, it wasn't just Intel, it was Intel or AMD, but basically it was coherent and also probably easier, but not so. But there are many use cases where it's better to use different infrastructures. Then GPUs came into the picture, and now we have lots of different type of accelerators. Also, some maybe not used but planned. We have the European Processor Initiative that may lead to some additional, let's say, processors, as the name suggests, and also we have many systems on ARMs or on mix of ARM and other architectures, like in case of, for example, in the newest Cyphernet system, Helios is based on Grasshopper architecture, which is a kind of combination of ARM CPU with NVIDIA GPU. So also during my work, I've briefly analyzed other emerging as systems like GraphCore, which was the one of accelerators aiming to build a kind of clusters composed of multiple nodes, but visible as single accelerator. So of course, not every every system of this kind would succeed, but it's the important aspect of my work for my thesis is to look for opportunities to find those well, cutting edge or emerging systems that may be well used for, well, on the one hand to get interesting early results and on the other hand, of course, to be useful for a set of application or application of class of applications. So, of course, while looking for very emerging and new infrastructures, I cannot, well, forget about classical infrastructures like supercomputers, clouds, and other similar, well, animals. So during my work, I focused both on well, actually on all of those. So various clusters and different cloud providers, as well as some installations based on our local cluster, mostly used for, well, for privacy. So yeah. So after all those initial work, I've defined a hypothesis, yes, so that it would be possible to use various well, models and predict performance of application and optimize the execution regardless of the backing infrastructure. And this would be, well, my ultimate goal. And to reach it, of course, I had to start from basics. So I've performed a set of the state-of-the-art analysis. One was related to, well, applications on Sano, because of course my PhD here at Sano is quite unique. So basically I am trying to help various well, other people at Sano in optimizing their application, and in doing so I can collect interesting cases for my work. So after this analysis, I found out two class of applications. One quite typical for HPC, so strongly compute intensive applications, which would require, well, on the one hand, scalable system, on the other hand, maybe some multi-site deployments are possible. But at the same time, I also found out a class of application which is more about storage network, memory optimization, and not so much about CPUs. Of course, there might be mixes, but just trying to well, provide some categorization. I also, well, looked at on various monitoring and metrics collection tools. So we have a set of really great tools, but well, designed for, let's say, different usage. So they're the first group, as I thought, as I presented before, it's possible to adapt them like Zabbix for scientific case and for infrastructures we are dealing with here, but it's not flexible and it leads to various problems. So well, I decided to go more with other especially open source solutions that can be is maybe not easily, but can be adapted to my goal in more manageable way. So like shown here, Prometheus, Grafana were my initial ones. I also started later cooperation with some colleagues I will mention later who and on the basis of OpenSearch, and yes, they are not all not well ideal, but they can be well tweaked for my goals. And of course, why they are not ideal? Because, for example, the most well-known probably Prometheus is usually trying to work in full mode. So it's collecting data from services because it was created to monitor services. And it would be great for many cloud cases, but for example, for batch processing, you would need to use some intermediate solutions which exists but are not so well but are not always the best way to deal with the problem. Okay, another aspect is getting data from the application itself. We can do it at least in at least two ways. One way would be to actually modify the application itself or part of pipeline to instrument it and to collect data, and it's one of the most well-known mechanism. Also, another probably equally common is analysis of logs produced by the application. As we can see here, for example, there is an open form application running and it's producing some informations like the execution time and the simulation time, and we can use those numbers to get meaningful and also clock wall time is called here clock time. So we can use those information to estimate how efficient is our application and estimate how long it would take to compute or to simulate a given, let's say, task. So getting back to those two cases, the compute intensive applications are those which I focus mostly and which I am focusing now. And this work is being I do this work in collaboration with Magda and engineer from University of Sheffield. So basically, I've got a use case from this team, and it's a really great use case related to the to calculation of blood flow in veins. So I've already worked earlier in this Kobo-Eurovalve project and with similar cases, but related to simulation of coping with valvular disease, and this time we are focusing on lower, or they are focusing on lower limb, and my part would be to plan how to run those simulations in most efficient way. It's really important because if at some point we would like to do the VUQ analysis, then we would need to run many computations in parallel, and each of these computations can take not just hours but sometimes days. Of course, we are trying to also optimize runtime of single simulation, but it's a really interesting case from my point of view because we can run part of each subset of tasks on potentially different infrastructure, while each computation is tightly coupled case and require to an appropriate well, low latency interconnect. So it's interesting. And what up to now, I've done some computation and some measurements on two HPC systems. The first one was, of course, ours, which is the Cyphernet supercomputer. Obviously, it was easiest for me. As we can see from this first diagram, the computation itself is pretty efficient. We have correlations between the hold time and the CPU time. At the same time, well, here I've run a set of simulated patients. Of course, the data is still not the real world data, but it reflects different cases, different how to say, different anatomies, and we observe that depending on the complexity of the anatomy, there are different times. My goal now is to run more cases and find this better understand this correlation between anatomy and the runtime. Also, we've obtained a test grant on LUMI supercomputers. So this is one of the fastest supercomputers in the world, and of course fastest in Europe up to now. The new coming, but for now, and we tried to compare some computations between RS and LUMI. We had, those are CPU times, so the lower time is better, as we expected. The newer and more powerful supercomputer was a bit better, but then it's also quite busy system. So there's also part of my work how maybe sometimes, I don't know, waiting time would be prohibitive, and it would be better to use a different system, regardless of maybe not regardless of the performance, but even a less powerful system, but more available. So a bit more slides from the same case, and finally there were some, we also this is a different case. So instead of changes of anatomy, I've took cases with different initial parameters, and based on that initially I was trying to establish how this let's say what's the relation between those parameters and the performance of the system and the computation. So this is yet another case. So obviously not one. I would say there are two very well known very known cases for physics-based simulation. One is computational fluid dynamics, which I mentioned a moment ago, and the other is a finite element, which is used and in collaboration with my colleagues from in Silico Watt project, I've I started work on analysis of the performance of the problem in the slide here. So it's also I would say computation used to estimate the risk of bone fracture. So it utilizes well, ANSYS mechanical, and it's being run for really huge cohort of patients. So it's interesting how each how calculation for each patient differs from others, and is there a difference? And we observed that in initial tests that actually there is a difference, and we need to and appropriate scheduling may be required to perform computation in required time. Okay, so I can see there is a question, so maybe I will quickly before it's just in the right time, because I will soon move to a different case of problems. So a remark will do recently.
It is a remark from Olaf.
Yes. So there has recently been open source. The HPC monitoring system is also under review. So this is really thank you very much for this information, and certainly I'll as I'm still maybe not doing strictly state of the art, but I am always looking for a new and better solutions. So this is really valuable, and I'll certainly have a look at that. So yes, so the coming back to those classes of those applications. So the second class is data intensive application. I actually started with that, but as well, but for various reasons, especially obviously the big machines are usually well suited for CPU intensive stuff. I focused mostly lately on the first class, but obviously this is also a very important class of applications, and related to genomics, transcriptomics, and in this case we actually I focused on a set of two type of pipelines. It was in collaboration with Sabina Lichova and the new data team, and both pipelines start from the so-called SRA toolkit, which processes the genomics data, and then there are two tools, one for pseudo alignment called Salmon, second for alignment called STAR. And actually, the goal is to find which tool would be best for in which case, while taking into account that those tools require significant amount of memory, and by significant I mean sometimes more than let's say our supercomputer can provide. For example, typical in 200 gigabytes require large so-called large memory nodes, and in extreme cases about 800 gigabytes of memory is more than even provided by these large memory nodes. So we would need to move to either different infrastructures or different cluster. So this just shows how sometimes, and obviously lack of memory would completely preclude the possibility of running the computation, which is even worse than a case where we need to wait a long time, because finally we can compute something in, I don't know, 7 days, as long as the queue would allow us and would not terminate our job. But this is just configurational aspect, but without sufficient memory we would not succeed at all. So finding best so matching infrastructures and tasks in this case is also very important. and here is just one of those workflows I want to focus in soon to reach this goal. So I am slowly turning toward conclusions, but I think that I am more or less it's all I wanted to say for that, but I would still of course would like to provide some conclusions. So summing up, I've already performed the state-of-the-art analysis for both applications and infrastructures. Most of the work is in collaboration with people from Sheffield. As obviously this is very natural collaboration for me. I've been working with the University of Sheffield for something like 12 years, if I'm not mistaken, or 13. So on various projects. So this is this, but I am always open for different collaborations, and as I showed, there were some. We are also yes, and what's more, I would like to on the one hand broaden the scope of this analysis, and on the other focus on other important aspects, especially green computing, which is now very modern, a very popular aspect, and it probably would be even more important in the future with of course ecology on one hand, but also economy on the other hand, with rising prices of energy and limiting resources. So with that, I would like to thank you all, and of course I am now open for questions and discussion. So
Many thanks. Many thanks. Well, it is time for questions and suggestions to Jan. Well, my first question is related to the result you have presented. You have presented the results which are about performance, which are somehow specific in the sense that they are results on a specific type of computer. So do you think that it will be possible to make these conclusions which will follow from this investigation more, let's say, general, to which extent it will be a conclusion about the way in which specific medical models are implemented, and how much they will be linked to these specific architectures?
Certainly. So, of course, for now, most of my research was on either single cluster like RS or cloud system, and I've just done some brief exploitation of Lumi supercomputer. But the most interesting, in my opinion, here would be to find, is it just the difference in performance, in raw performance between the systems, or is there some configurations like some, I don't know, over utilizations of the nodes, and maybe it's and how application can be. Yes, and is it a problem related to, no, maybe not a problem, but is the difference related to application itself or the infrastructure? So I'm not sure if this is what the question was about, but I would certainly like to find a solution, a model that would be independent of the infrastructure. So.
Well, thanks. What about other questions from our side? Well, in in the meantime, I have another question, namely, in a good, maybe not good, let's say this in such a way, in many computer centers, at computer centers, there are some, let's say, a group of people who follow most time consuming applications, and they are trying to give some advices to people responsible for these applications. And well, it is a kind. Do you think that your research will somehow help these people?
I certainly hope so. So for now I wanted to collect as much information as possible, because I don't want to, let's say, waste anyone's time. Yes. So if there is some problems that are, let's say, configurational specific and not generic, I don't want to well, provide information that it's not as complete as possible. But for example, for OpenFOAM, which I used or actually which was used and I monitored in those cases, I had to use containerized version, because there were some issues with pre-installed version. And I think when I fully diagnose the problem, I can provide feedback to the administrators or dedicated or dedicated team responsible for, as you said, for maintenance of the applications, and I hope it would be useful. So yeah, thank you. I can see there was a question on question and answers, so I'm not sure if I answered your question first.
There's another question coming from Keith.
Yeah, so that's what I'm saying. So maybe I know I can read it, maybe, because I'm not sure if probably everyone is not seeing it. So Harian, good to see Metro PhD student. We need to stick together. For me, the big question is how you decide between cutting edge methods and provision of stable mechanism for Sano research teams. Easy? Certainly not easy. Yes, so this is a great question. And I think that's why I showed those two slides. Yes, we need to, so I'll just quickly get back to them. So this and this. So here we have some cutting edge solutions, like, I don't know, combination of graphic cards with network cards that might be good for distributed learning or generally distributed AI. And here we have some accelerator which may or may not be successful. So this is a nice, I think, add-on, or if there are some infrastructures that we can consider low-hanging fruit, then certainly I would like to check them up. But especially that this is a PhD, so this exploratory and this novelty aspect and research aspect is really important. But at the same time, we still need to stick with classical infrastructures to provide, let's say, stable way for research teams, because this is really this is even more, the PhD is very important, but finding the way to improve performance of applications that can help people is probably the most important here. So I'll try to do a mix. Certainly not an easy task, but I hope to have a model that actually maybe in ideal situation would be able to to suggest where to go, to stick with one type of infrastructure or another. So I hope that answers the questions, but yes, this is really, really, really interesting aspect.
Well,
Okay.
thank you, and thank you, Keith, for your answer, for your question.
Very much.
And well, we're looking for questions, and well, I don't see more. Well, there are not. Maybe I'm mistaken. There are not more questions. Oh,
Someone, I saw a raised hand, but I think it's no longer there.
raised hand.
So, well,
No.
okay. Yeah, so maybe I'll just add a quick comment. Oh, okay, sure.
Yes, it is another question coming from Keith on questions and answer. Mechanism for secure connection to external data.
Oh, so yes, this is interesting. So obviously we have a mechanism like VPNs or like HTTPS, so all those basic mechanisms that would what we call secure what we call data in transit. There are also some mechanisms to secure the data at rest, so the data stored in the systems, but part of this cutting edge infrastructures, which I certainly would like to take into account, is to secure data during computations. So here we have this secure encrypted virtualization and Intel SGX. So one is from AMD, one is from Intel's, which actually encrypts memory, random access memory, and so unencrypted data is only stored inside the CPU itself, so which practically makes it nearly impossible to extract it. And this is some attempt to provide what they call confidential computing. So to enable usage of clouds in a way that we can be maybe not sure, but more assured that cloud vendors or cloud providers won't be able to hijack our data. So I think this is the most critical aspect here, and obviously this may strongly hit the performance, yes, because we are talking about decrypting and encrypting data during computations, which is done in hardware, so hopefully not would be efficient, but it's certainly something I would like to have a look. And I think it's also a part of one of our projects here at Sano, so I'll hope to collaborate with the team responsible for this. So yeah, thank you very much for one more great question.
And we have Jose.
Maybe, yeah, so maybe we can let Jose ask the question, yes, and we have Keith in the queue.
Jose, can you please ask the question?
Can you hear me? Can you hear me?
Yes, maybe not perfectly, but we can hear.
Okay. So my question is that, first of all, thank you for the presentation. I think it creates a very nice picture about what you are aiming to explore. So my question is that, so you mentioned on the presentation that you'd like to understand how this can be translated or can be used, how the performance of high performance computing would have an effect on medical decision making, if I got it right. So my point is that typically you have two moments for the decision making in medical application. Here's one, that you have an automatic decision making process, so you would know the answer, so you have your models trained, and those models will provide an answer to the question that you see in front of you. The other would be, okay, I would need additional reasoning or machine learning, whatever, to find an answer. Do you see, your pipeline and the approach that you are taking, helping to understand how that could be deployed in a I would say real case scenario? So taking, for example, a hospital, or taking, for example, a decision around a certain disease.
I think that it would be a really good next step, and it could be. I am not sure if I've got you correctly, but I remember during my previous work there was a case which actually was not an AI per se, but it was about building the so-called reduced order model for a heart, and it was because there were significant computation power could be used to develop the model, but the goal of the model was to be run at site in the hospital where there is no HPC, and so obviously there were completely different completely different conditions in both places. So I think that while I haven't worked so far here with AI models, I think that it's something we certainly need to discuss in details, and maybe maybe create a model that would accept some trade-offs, like, I don't know, requiring more resources for one part of the computation where we can afford it, and to even to make the end, I don't want to model to make a tool to be run at hospital even more efficient. I'm not sure if this is what you asked.
Because you mentioned that you are focused on the efficiency of the computing, okay?
Yes.
But those two scenarios, they demand different approaches. Okay.
Certainly.
So one really would like to be efficient, because you would like to to use all the resources that you have to compute in the shortest time possible. But for example, on the automatic decision-making part, you would be more focused on the accuracy of the result that you are giving, So
okay,
the efficiency that you provide. So I think that trying to unify this in a single architecture, even if you use different technology, because you mentioned a lot of the technology that you are using, I think I would say that the challenge is more on the architecture than it is on the technology that you are deploying, because you can deploy an agent or whatever, or a container inside a GPU or inside a server, whatever. So now.
Yep. I get it. I certainly concur. So basically, I think that maybe we would need to have some. I don't think it would be one model, but we can certainly focus on the creation of models answering those. Well, as I said, about security, there is always a trade-off between security and performance. So what you said, it's also important. There might be a trade-off between performance and accuracy. Also, I know that there are even some notions of optimization of re-engineering of algorithms, so they would be more, let's say, green friendly, but less accurate when it's wherever it's acceptable. So certainly this is something to think. But I haven't think about it yet. But let's talk a bit more about it. Yes. So thank you very much. It's a really great remark and great question.
Okay, thank you. Thank you. Very nice presentation.
Yeah, thank you very much. And I can see there is this question from Keith, so I will read it because it's on the Q&A. Is there a business here? Can Sano develop mechanism for medical applications that will mean AWS is poor second for us? Well, I think certainly there can be a business because, well, first of all, we would like to well optimize usage of the available infrastructure. So making it less wasteful, we are well conserving money, and I hope the solution can be well how to say it can be we can create a solution ready for market. Yes, so that can provide well it can be commercialized and other people may also benefit from the work. Also, there is a different way for commercialization. So, for example, there was already there are many cases where, for example, I don't know, spot instances from different providers can be used while which are and spot instances are much cheaper than regular ones, but require well, application needs to be ready for well, quick eviction, to put it that way. So, for example, when the resources are needed, the provider would give you 30 seconds, for example, and then kill your application. So it's by contract, but you are of course saving a lot of money. So building I don't know, a platform that balances the load, including possibility of using of such mechanisms, can also be either used internally or can maybe be commercialized as a kind of, I don't know, software, maybe not as software as a service solution, or some broker as a service solutions for I don't know, running application in most efficient and most cost efficient way. So certainly I think we can think about well, commercialization possibilities as a result of this work, or at least I hope so.
Okay. Well, I do not see more questions at that time.
I think we've got really interesting
think,
discussion,
yes.
and of course, maybe I would like just to add from myself that there was well, I'll go to the last slide. So there is my email, and oops, I won't go on too far. So there is my email, and I am certainly open for possible either use cases or tools. So if you as like Olaf was sent here, so if you have some ideas for some monitoring platform, or some interesting cases, or maybe or especially something related to some simulation platforms, open source especially simulation platforms, I would be really grateful, because there is one aspect I haven't mentioned related to of course licensing. It's obviously some packages are commercial, and in which case it might not be feasible for licensing or for financial reasons to well test them on extreme scale. So yes, so I'm always open, and I think yes.
Okay, so many thanks for everybody. Many thanks first of all to Jan. Many thanks for everybody who participated in our seminar today. And well, we will have the next seminar in a week from now, and it will be also a presentation of research performed by one of a Sano PhD student. So many thanks, and see you in a week from now.